Geometry lesson 6-5. We spent quite a bit of time talking about parallelograms. Now we're going to still deal with four-sided quadrilaterals. We're just going to switch and talk about some other shapes that are quadrilaterals that are four-sided shapes. So our first one is what's known as a trapezoid. And the key with a trapezoid that sets it apart from a parallelogram has two sets of parallel sides, whereas a trapezoid is going to be the same four-sided type of shape, but it's going to have exactly one pair of parallel sides. So it's not one of those situations where a square is a rectangle, but not all rectangles are squares. It's not that at all. It either has exactly one pair of parallel sides, or it has none, or it has two. And if it doesn't have exactly one, then it's not going to be a trapezoid. It would either be one of the other types. We talk about the trapezoids themselves, and we have the two parts that are parallel to each other are known as the bases. And it doesn't matter which one you refer to as base 1 or base 2. That really doesn't matter because the trapezoid itself can flip upside down. But they will be parallel. The bases are parallel to each other. The parts on the sides are known as the legs, and they may or may not be congruent to each other. All right? It is possible that you could have a trapezoid that looks like this, where you have one line that's parallel to another, and a little longer on one end, and then it is vertical on one side and slanted on the other. This is possible. There's nothing wrong with this. If you see this, you still have a base and a base, a leg and a leg. So that's fine. All right? So those are a couple examples of a trapezoid. Now with that, we have what we call isosceles trapezoids. And then isosceles trapezoid, that's where the legs are actually congruent. So my initial trapezoid that I drew would probably be more of an isosceles trapezoid. With an isosceles trapezoid, you still have the lines that are parallel. The legs have to be congruent. Right? Theorems for trapezoids. So these are very specific to trapezoids themselves. First of all, if a trapezoid is isosceles, so if you know that both the legs are the same, then each pair of base angles are going to be congruent. The base angles are congruent. This is a little different. Most of us start thinking about opposites, but with a trapezoid it's on the same, okay? Down here at the base. And up above, these base angles are the same. Now it's still a four-sided figure. That hasn't changed. It's still a four-sided figure, which means the entire diagram here is going to total 360 degrees. That hasn't changed at all. But no longer are we looking at it and going, oh, the opposites are the same. Now the base angles are the same. So with the two angles on the same base. And with that, if the trapezoid has a pair of congruent base angles, then you know it must be isosceles. So say maybe you didn't know these two lengths were the same. You knew you were dealing with a trapezoid, and you were given the fact that the measurements were like this for the angles. You would be able to conclude from this information that you are dealing with an isosceles trapezoid based on the angle measurements. Some more about trapezoids. A trapezoid is isosceles, and remember this stands for if and only if. Its diagonals are congruent. So if your diagonals of your four-sided, your quadrilateral that's a trapezoid are not the same, it's not isosceles. So they have to be, in order to be congruent here and here, the diagonals have to be the same. So A to D would be exactly the same length as C to B. If they're off by even so much as a little bit, that means these legs have to change, therefore they would not be the same length. And we've talked about a concept similar to this before, midsegment. The midsegment of a trapezoid is a segment that connects the midpoints of the legs, and it will be 1/2 the sum of the bases. So here's a situation. If you have a trapezoid, and this is the midsegment, which means this measurement right here is the same as this measurement here, and this measurement is the same as this measurement. Take these two and add them together. That gives you 15. Cut it in half, 7.5. Formula, FE is equal to 1/2 the lengths of A to B plus D to C. In other words, take that length and add it to the bottom length, add the two bases together, cut it in half, and you'll know the exact distance of the mid-segments of the trapezoid. So that takes care of all of our relationships that have to do with trapezoids. Now we'll move from trapezoids into our next four-sided shape that is not a parallelogram, and it's what we call a kite. Now it's still four-sided, still a quadrilateral, but it has two pairs of consecutive congruent sides. So they're not going to be across the shape from each other. They're going to be right next to each other, not opposite. Okay? the opposite sides are not actually congruent. So this is an example of a kite, and you'll notice that this is consecutive because they're connected. These two are consecutive because they're connected. So these two are the same, and these two are the same. They're not opposite each other. Opposite would be like if those two are the same, which they're not. So some definition and pieces of information regarding theorems for kites. If a quadrilateral is a kite, then the diagonals will always be perpendicular. So if you're truly dealing with a kite, and this is kind of the traditional kite that we always think of with the two sticks that crisscross each other, and they would cross each other at 90 degrees. Alright? But if you don't have 90 here, then you know you're not dealing with a kite. Even if it's 89 degrees, then it's not a kite. A kite would always produce 90 there. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Not two pairs, exactly one. These two right here. These two are not going to be the same. In order to be a kite, there's going to be exactly one pair. D and B are not congruent. So, if we look at our first example, we know that GHJK is a kite, and we want to find the length of H to P, which is called X in this problem. Now we know, because it's a kite, the fact that it is a kite means that they must be crossing, the diagonals must cross at 90 degrees. So we are dealing with a right triangle, and you have two legs of the right triangle and a hypotenuse. Sounds like the Pythagorean theorem. X squared plus 5 squared is going to equal the square root of 29 squared, which means x squared plus 25 equals, the square and the square root cancel out, 29. Subtract 25 from both sides. You're left with x squared is equal to 4. And to solve, square root, the x squared, the square and the square root cancel out, and x is equal to 2. Excuse me. In reality, it's plus or minus 2, but in this case, it doesn't seem very logical to have a negative 2 measurement right here. So that's the value for x. That's the length of x in order for it to be a kite. Now, if x is something else, then it's not going to be a kite. All right, last example. RSTU is a kite, because we know it's a kite. Then we want to find the measures of R, S, and T. So the measure of angle R, the measure of angle S, and the measure of angle T. Now, because we know that in all kites, there are going to be two that are the same, these two have to be the same. So that makes finding S pretty easy, 125 degrees. All right? And we know that a total of 360 degrees is in all four-sided shapes. So we can say x plus 30 plus the x at the bottom plus the 125 and the other 125 have to make 360. So that gives us like parts we can add. Here you have 1x and 2x. And here you have 125 and 125, which is 250. 250 plus the 30 is 280 equals 360 degrees, which is a simple two-step problem to solve now. Subtract 280, subtract 280. We're left with 2x is equal to 80, which makes dividing by 2 pretty easy. Final answer, x equals 40. Now we've got to go back to the shape. We now know that angle T is 40. And we know that the relationship with it and the one above is x plus 30, so 40 plus 30 is 70. If we've done this correct, it should total 360. So 125 and 125 is 250. 250 plus 40 is 290. 290 plus 70 is 360. We know we have the correct values, and the relationships are all the same.